Hi, welcome back to Dr. VASU'S lectures. Now, in continuation of our C language, we are going to see different types of systems like decimal, octal, and hexadecimal numbers, right? So here we are going to see numbers, integers with a different basis. To start with the decimal system, we are well versed with this system and we have been using regularly this. So it has a base of 10. It uses 10 numbers, 0 and 1 to 9, total 10 numbers, and its base is 10. Examples, you take an integer, A is defined as 10 or 0, B 0 or C minus 493 or something like that. So suppose if I say, even though it has no value in the left side, I want to represent a 345 like this, 0, 345. But here it is not allowed. Let us see why. Next comes the octal system. This octal system has a base of 8 and it has 8 numbers, that is 0 and 1 to 7. It is represented like this. That's why here in the beginning you should put 0. The meaning of it is in the octal system. That's why I told you in the decimal system we should not put 0 in the beginning. If you say this 0 in the beginning, that means it is in the octal system, not in the decimal. Okay. Now, suppose if I had taken 0, 1, 2, 3. 1, 2, 3 is the number which is in octal system. And I want to convert this into a decimal number. To convert this, we have to multiply these numbers starting from 8 power 0 on the right side. Next 8 power 1, 8 power 2 like this, right? When you go to the left, power of 8 increases by 1. So we take 8 power 0, 8 power 1, 8 power 2 like this. And this number is multiplied with this. 8 power 0 is multiplied with 3, 8 power 1 by 2, 8 square with 1. 1 into 64, 2 into 8, 3 into 1. 8 power 0 is 1. Put together 83. That means 1, 2, 3 in octal system is equal to 83 in decimal system. Okay, next. Hexadecimal. Coming to the hexadecimal, it uses 16 numbers and it has a base of 16. The numbers are 10 numbers, that is 0 and 1 to 9, 10 numbers, and A to F. A here, letter A is used as 10, B 11, C 12, D 13, E 14, F 15 like this. Altogether, all these are 16 numbers. Now, to indicate a hexadecimal number, we use 0x in the beginning. Like we used 0 here for octal. 0x indicates that this 1, 2, 3 is in hexadecimal system. It can be 0, small x or capital X. It doesn't matter. Both can be used. Now, this is another example. 2, 4, F. F means 15. That means 2, 4 and 15. This is the number in the hexadecimal system. That is 0x meaning that. Now, suppose if I take the same 1, 2, 3, which is in hexadecimal number, I want to convert this into decimal system. For this, again, we start with the rightmost number is multiplied with the 16 power 0, next 16 power 1, 16 power 2, like this. So 16 power 0, 1, 2, like that. 3 is multiplied with this, 2 and 1. 16 is 256. So 1 into 256, 2 into 16, 3 into 16 power 0, 1, 3 into 1, 3 into 1, equal to 291. That means in decimal system, this 1, 2, 3, which is in hexadecimal system, is equal to 291 in decimal system. So that is the meaning of it. So that's how we have to convert and use the numbers. So here, displaying integers. How we display this decimal system numbers? Let us see first. Already we have seen example, right? Let us see. So here, if you take an integer, a is an integer and its value is 237. I want to display it, the value of a. For this, I have taken %i and %d. So both can be used. Already we have seen. So that's why let us see how it displays. Compile this and execute. You get an output like this. So here the output is integer a is equal to 237. Whether you use %i or %d, both are same. Both gives you the same output. So this is the way of indicating an integer in decimal system. Suppose I take an octal number. I want to display an octal number. For this, I have defined this 1, 2, 3, which is an octal number because we put 0 here in the beginning. This is octal, but we define it as an integer only. Now, octal number, I want to display octal number just with the %o, right? Let us see what you get. Okay, let us see %o. O means octal. This value of a I want to indicate. Also, I'll write another one with a hash, a symbol hash, %o. Same a I want to represent. Let us see how will be the output or display. So here, if you execute this program, compile and execute, we get an output like this. First one, %o I have written, octal number without leading 0. We don't have a 0 in the beginning, just 1, 2, 3. Next, when you put a hash here, I got a 0 here. This is, both are, a is an octal number, but here it is indicated as 1, 2, 3, but here it is indicated as 0, 1, 2, 3. We get a mistake that we may think that it is in a decimal system. 1, 2, 3 is in the decimal system, but it is octal. That's why this leading 0 must be there. So to have this leading 0 in octal system, we must keep this %o. Clear? Next. Let us see hexadecimal numbers, how they are displayed. So I take a hexadecimal number. You can take any examples. Hexadecimal, these are all defined as integers only, whether octal or decimal, or hexadecimal, they are defined as integers only. So integer is used, but we have to say, specify that it is an hexadecimal. There. Now, 1, 2, 3 is 1, A3DF, 3, 4, BD, all these are all hexadecimal numbers. Now, let us see, the same principle is used here. I want to display A, B, C here, right? A, B, C, 3 integers. But %x only I have used here. Here, %#x I have used. Let us see the difference. Same ABC I am displaying. So, hash I have used here in between. So, %x actually for hexadecimal system display. But here, this hash has a role. Let us see what it is. Complete the program. Compile and execute. You get, in the first set, I got 1, 2, 3. That's all, right? A3DF, 3, 4, BD. That's all. I have a doubt here whether to use this 1, 2, 3 is in a decimal system or hexadecimal system or octal. We don't know. That's why we have to use this hash symbol to get this 0x here in the beginning. When you have this 0x in the beginning, we understand that this number is in hexadecimal system. That's why this is a mistake. This you should not use. Only you have to use this %#x to display hexadecimal numbers. Next. Suppose I have taken some other same numbers, right? Just to show you the difference, I have taken capital X. Here, I have taken capital X, and again without hash, with hash. Let us see the display, how it will be. So the output, without hash, we get A3DF. That's it. You may say that when you have A3DF, it is in a hexadecimal system only, but the system cannot understand that it is in a hexadecimal system. And also, suppose if you don't have these numbers, and suppose 1, 2, 3 or 7, 8, 9, 4, 3, 2, something like that, there is every possibility of getting a mistake that we assume that it will be the number in the decimal system. To avoid that, we must use this 0x in the beginning. And one more thing, if you observe, earlier we used small x, then also we got a x here, but a small x. And all these numbers are in small letters. Now, because I have used a capital letter, we got that in the capital. All these numbers also got in capital letters. It doesn't matter whether they are written in a capital or small letters, but here this is the difference. So we have to use %#x only to display hexadecimal numbers. Clear? Displaying integers of different base. Just let us see. Have taken different numbers, right? Different 3 numbers in different systems. This is 237, right? In a decimal system, decimal number, %i is used, right? Hexadecimal number OX. So %#x is used. For octal, %#o is used. Compile it and run to get the numbers like this. Hexadecimal with 0x, octal with 0. Just to have a summary of it, how to display the numbers of different bases. Okay. So with this, we have finished the integers with the different bases, right? So next, in the next video, we are going to see the floating point data types. Thank you very much. Please subscribe to Dr. VASU'S channel. Thank you.